Alrighty, so topic 7 in Unit 5 is about linear regressions. And you may notice that this screen looks a little bit different than a lot of your past videos. And that's because we have this Casio calculator on the left-hand side of our screen. You are going to need your calculator for this lesson. So if you haven't gotten it out, maybe pause the video and go get it. And I'm going to do my best to try to show you the keystrokes I'm doing with this Casio emulator on the left-hand side of my screen. It may not look exactly like yours, but all the buttons are in the same exact places and it does the same exact thing on the screen. I do recognize that this is a little bit small, but even if I shift my split screen here, the calculator always jumps back to the same size. So you're just going to have to wear your glasses or zoom in on the video if you can to try to see the different keystrokes, that's what I'm trying to say, for the calculator. And if you have any extra questions about the calculator when this is over, just make sure you reach out to your teacher and they can provide you some extra resources or maybe talk you through it. Okay, so let's get started. Number 1 says, consider the data below showing the number of visitors to a new zoo in Abilene, Texas. So we have this pretty table. Part A says just to make a scatter plot of the data on the graph at the right. So I'm going to assume that the top here is our X variable, our independent data, and then the Y is on the bottom. So my first coordinate would be 0, 2, 55. So I can tell each one of these lines, our scale here is counting by 100. So 255 would be somewhere here in the middle there. My next coordinate would be 1, 302. Next one would be 2, 475. 3, 646. 4, 920, 5, 1121. Okay, so we've got our data on the graph. Now remember, you don't ever want to play connect the dots when you're making a scatter plot. That would serve no purpose as far as algebraically how to work with this data. So part B says, does the scatter plot show a positive, negative, or no correlation? Well, in general, those points are increasing as we read the graph from left to right, so this would be a positive correlation. Part C says draw a trend line. Hopefully this is something you are familiar with. This is where you draw a straight line that goes through as much of the data as possible, but if it can't hit any points, it needs to make sure that it's got about half the points above the line and about half the points below the line. It's kind of like you're creating an average with that line. Remember that your trend line does not need to go through the origin. That's a common misconception. This data doesn't look like it would go through the origin, so we're not going to try to force that. I'm going to say that it would be somewhere in here. That wasn't very good, but the cool thing is my Apple Pencil, if I hold it down, it kind of snaps to, and I can see a beautiful trend line with about half my points above and half my points below. Okay, so this trend line shows the steepness of those points as well as the direction. So then part D says, what is the approximate equation of your trend line? Well, to write an equation, we need y equals mx plus b, the slope and the y-intercept. So looking back at this graph, if I'm to find the slope, I need to find 2 perfect points. Well, when I made this line, I wasn't trying to look at perfect points, so it may be kind of hard to find, but we're just going to do the best we can. I would say this one looks pretty good, and maybe this one up here. Just do the best you can to find 2 perfect points, and if you have to kind of fudge it a little bit, that's okay. So rise or run, remember that this scale is counting by hundreds. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. So that's 800. And then this is counting by ones. Whoops. 1, 2, 3, 4, 5. So we've got 800 over 5. So if I was to simplify that, we would have 160. Okay. So my slope would be 160. Put an X next to that. My y-intercept would be, looking back at my graph, we'll just say 200. I would agree that maybe it's a little bit above, but we're just approximating, so plus 200. Okay? Now, part E is what this lesson is all about. It says use your calculator to create a more precise equation to match this data. So our calculators have the capability of performing hundreds of thousands of tiny little calculations to ensure that they're going to create a line that is perfectly in between all the points. It does a whole bunch of averaging, a whole bunch of different deviations to try to figure out a line that is perfectly in between and representing as many of these points as possible. Okay, so here are the steps in this little dotted line box at the bottom. This is what I'm going to walk you through over here on the left-hand side on this calculator. So the first step is to enter the data. So you want to first press menu, which is what my calculator screen already shows, which is all the different applications. You're going to press statistics. So that is the number 2 function. So I pressed the number 2 on my screen. Then it says to enter the X values in L1 and the Y values in L2. You'll see this little table has a variety of lists. When it says L1, that means list 1. So I'm going to go up to my table. I want to enter my X values. So I'm going to tap 0 and I'm going to press enter to go to the next line, or EXE, which is execute. I'm going to tap 1, enter, 2, etc., until I have all the way to 5. Again, I'm just putting all these in the X list of my calculator. Now I want to do the Y list. So I'm going to press the right-hand arrow on your little circular keypad. I'm going to press the right arrow to go over to list 2. Now I'm going to put all the Y values. So 255, enter, 302, 475, etc. Excuse me. And make sure to do this along with me so that you can kind of make sure that you're doing it correctly as you go. Okay, so you'll know that you've done everything correctly when you finish, you see that last point matched up together. So 5 with 1121, we can see on our screen we have 5 with 1121. Okay, so again, looking at our steps, we've done that first column, which is enter the data. Now the second step is to look at the graph. So it says press graph. Well, if you see over on the calculator screen, you have all these words at the bottom: graph, calc, test, INTR, whatever that means. You have all these things. The way you click on those is to click the F buttons, which are directly underneath them. So for example, if I want to choose graph, like it says, I need to press F1, which is directly underneath it. Okay. Now it says press set and choose scatter. Over where it says set, that actually stands for setup. So we're going to press F6 to set it up. And you'll notice it already says scatter. Okay, the very first option, if I arrow down, says scatter. You can actually choose different types of graphs, like a pie chart, a line graph, but we want to create a scatter plot. So I'm going to leave it there. While I'm here, I'll go ahead and show you that this is where you would choose what creates your X list and your Y list. So we've already had that set as list 1 and list 2. If you scroll down a couple more where it says mark type, this is where you can choose the icon that it uses to mark your points. So for example, if I want solid dots, I might choose F3 here to create a solid dot. Or if I want the little X's, I might choose F2. You can change what it looks like. You can also keep scrolling down and choose different colors, all kinds of different things. Okay? So looking back at my list, I've chosen scatter, and you really only have to do that one time. Then I need to exit and press graph 1. So I'm going to press exit. Then I want to go ahead and put this into a graph. I want to look at a graph. So we're going to choose graph 1, which corresponds to F1. And there's my points. Okay? You'll notice the calculator zooms in for you to the correct window that you need, which is nice. But if you want to zoom out or zoom in, you can always use the plus and minus keys at the bottom, like the addition and subtraction sign, to zoom in and zoom out, just if you're curious about seeing the bigger picture. Okay, so now we're on to this third column. This is where you actually make the equation. So step 3 says to press calc. So on your screen, you see those two options. F1 is directly underneath calc, so I'm going to press F1. Then it says press X. Oops, that's because we want a linear equation. X is in our linear equation, so I'm going to press F2. Then we want it to look as much like mx plus b as possible, so we're going to choose ax plus b. They're just using an a instead of an m, but it's the same thing. Now I have this crazy looking screen that has given me the different values I need to write my equation. So just like we normally do, we're going to try to write y equals mx plus b. So y equals, well, the slope, m. For the calculator's purposes, they've assigned an a to that slope value. So looking at my list, they're telling me, hey, a equals 181.571, blah, blah, blah. So that would be my slope, 181.571. And I'm going to stop at the thousandth place just because you'll see that commonly, but as long as you're rounding appropriately, just read your directions and your teacher will tell you how to round. Okay, x plus, I need my y-intercept. Well, again, it's still a b in this case. You can tell at the top it says ax plus b. So they say the y-intercept is 165.905, because that's 7 tells the 4 to go up. So there is my precise equation that is exactly through the middle of all of those points, okay? If you compare it to that equation that we made, it's really not that far off, right? In the grand scheme of things, a slope of 160 is pretty close to a slope of 181, right? Same with our y-intercept. 200 isn't that far off from 165, okay? So that right there is a linear regression. Your calculator just performed all kinds of fancy calculations to give you a precise equation, okay? So a regression, what is a regression? A regression is a calculator-generated equation for a line, and then I'm going to put in parentheses curve, because it could be an equation for a quadratic too, of best fit. Okay? So it's the most precise way to come up with an equation for a line of best fit, or later, when we do quadratics and exponentials, a curve of best fit. So, the cool thing about that is that it can really help you to make really exact predictions. So if you're thinking about when would I ever use this, this is actually used quite a bit, because this is going to be a much more precise way to make predictions for like purchasing, right? If you're trying to figure out supply and demand, well, you can make predictions about a population over time, or spending habits to try to figure out how much of a product you should buy, or what it costs you should sell it at. This kind of stuff is used quite a bit in a much more streamlined and probably sophisticated way, but the basics are here. So it says, how many people would you predict would attend the zoo 20 days after its opening? Well, if I go back to this original problem, 20 days, that's an X value, right? The days were our X value. Well, if we have an equation that's going to tell me how many visitors will be there after X days, then we can just use that equation we just came up with, 181.571, but instead of X, we're going to plug in that 20 plus 165.905. So now I can go back to my calculator. I'm going to press menu, go to menu 1, which is run matrix, and just type this in, 181.571 times 20 plus 165.905. Press enter. So I can predict that there's going to be about 3,797 people in attendance at the zoo. So again, the zoo might need to know that. They might need to have that prediction ahead of time so that they prepare for staffing needs or for how much food to purchase for the park that day. Okay, you'll notice that I didn't write 3797.325 because our unit here is people. You can't have 0.3 of a person, so I just cut that part off. Okay? Now, the rest of these notes get a little repetitive. So there's going to be times where I just give you the equation, but I would still recommend that you pause the video and try to work it out yourself to make sure that you're getting it correct each time. I just don't want to bore you by walking you through the steps each time. So, second page, I am going to do the whole process with you one more time. Now, I'm not sure if your copy looks like mine or not, but my graphs are very messed up. So the table for number 2 actually corresponds with the graph that's down here on this problem. Don't ask me why. So these points, -416, -215, we're going to put down here, okay? So we're just going to graph these, find the linear regression, and then answer these questions. So -416, which is not actually on the graph, but it's close. -416, -215, -113, 311, and 79. 311, 79. Okay, so again, if I was to come up with a line of best fit, I might draw it somewhere in here, maybe, but even that's not very good. So let's let the calculator do the hard work for us, okay? So don't worry about the graph. We're just going to focus on this table and putting it into our calculator to find the equation and then answer the questions, okay? So again, going back to your calculator, you're going to press menu and make sure that you are in the statistics screen, which is number 2. Now, this data is in there left over from problem 1. If you want to delete it, I typically just press the delete key over and over and over until it clears out each number. Scroll over to list 2, same thing, delete, 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 delete. Okay. But I'm going to arrow back to list 1. I'm going to put in my x values. -4. Whoop, there's a little bit of a delay. Enter. -2. Enter. -1. Enter. 3. Enter. 7. Enter. Okay, I'm going to arrow to the right. 16. 15. 13. Let's say I got confused and I typed 9. Okay, you'll notice right off the bat I can see that I messed up because I don't have a value to go with 7. I can see that I accidentally skipped a number. And in fact, if I try to graph, it's going to give me an error message. It says no data. That's because I mismatched my data. I didn't actually type it in correctly. If you get any kind of an error, that's really your first step, is to go back and look at your list of numbers and see if you typed something in incorrectly. So I'm going to go back through 16, 15, 13. I missed the 11, right? 11, enter, 9, enter. I could even try 5, enter. Again, let's click graph 1. It says no data. Okay, that's because I put an extra number, so let's delete that. Graph 1, still no data. Okay, so clearly I'm doing something else incorrectly. Well, the problem is that I put all these in list 3, right? If you remember when we clicked setup on F6, we told the calculator to look at list 1 and list 2. So I need to press exit. I need to go back through and make sure these are in the right spot. So I'm going to delete, delete, delete. List 2 is where I need to be. 16, 15, 13, 11. Let's say I mess up again. You're going to be so annoyed. Graph 1 still works, right? Now, this is where you have to be extra, extra diligent when you're looking at your data to make sure that you've typed everything in correctly, because it doesn't always give you an error when sometimes you have made an error. So this is a time where you really have to be detail-oriented to look closely at what you're putting in your calculator. Okay, now, you don't have to click setup every time because it'll keep your settings. So we're still doing a scatter plot. We still want list 1, list 2. So I'm going to go ahead and click graph 1. Maybe not. Exit graph 1. There we go. Okay, those points do look quite a bit like the green points that I drew before. I'm going to click calc. I want x for linear regression. I want ax plus b. And I see all those pretty numbers there for me ready to write down. So my linear regression be y equals, I want the slope first. So in this case, it is that negative 0.639. Well, that 9 is going to be told to round up by the 8. But if the 9 rounds up, that just means the 3 rounds up. So really I've got 0.64 x plus 13.184, because the 9 tells it to go up. So there's my equation. And it says what would the value of y be when x is 4, and what would the value of x be when y is 0? Well, that's where you use that equation to plug in the values you have to figure out your missing value, right? This is done in your run matrix screen. So I'm going to press menu, I'm going to press 1, and I'm going to use this equation. So the first question says x is 4. So I'm just going to type in negative 0.64 times that 4 they just gave me, plus 13.184, and I get 10.624. Okay, then they say what would the value of x be when y is 0? Well, this time they're giving you y. So if I put the 0 in where the y is, I'm setting myself up to have to solve an equation. I'm going to have to work backwards here. I need to move that 13 over by subtracting it. I'm going to subtract 13.184. And then I'm going to have to divide by negative 0.64 to figure out what the x is. So negative 13.184 divided by negative 0.64. So I see that x would be 20.6. Okay, so still quite a bit of math involved, even though the calculator is doing quite a bit of work for you. Okay, now number 3. This one, this table is going to go on this graph. Again, I hope yours is not like mine, but if it looks like mine, something got moved around here. So -4, -19. Oops. Be right here. 5, 8. You'll notice these are out of order, but it doesn't really matter because we're still going to graph them the same anyway. 0, -7, -7, -28, 3, 2. Okay, so I'm going to go to make my line of best fit. I kind of just like to visualize it myself first. So these are actually pretty straight. And really, they're really straight, right? I could get a line that almost fits all of them. So we'll see what happens with this one. Go ahead and pause the video, put all those into your calculator, go through the calculator linear regression steps, which are outlined in this dotted line box up here, and see what you get. Go ahead and pause it. Don't just wait for the answer. Okay, when you do this one, you get a very simple equation. Your numbers are very easy to look at. You get y equals 3x minus 7. This is just a handy tool of finding a linear equation, really. It doesn't always mean that the dots are all scattered all over the place and require some weird, funky calculation. This was actually a problem that had a consistent slope all the way across, a very clear y-intercept, and it was really a very simple set of data. But that's not always the case. Sometimes it's a nice surprise, okay? So this one's calculations are going to be much easier whenever you have to plug in this data. So when x is -1, we'll just picture a -1 there. 3 times -1 is -3, minus 7 is -10. Y is -10, okay, picture a -10 there. If you add that 7 over and then divide by 3, you would just get a -1, okay? If I did that too fast, that's something you can ask your teacher about. But big star by that, okay? All right, number 4, last weird graph thing. This graph is actually up here, okay? So again, we're gonna mark this data on the graph. So we've got 5, then 4, and then 7 and 7. Then we've got 5, 3, and 6, 5, and then 8, 6. Here's a throwback question for you. Is this a function? No, because these do not pass the vertical line test. Okay, so now, this is a perfect example of if someone asked me to create a line of best fit, I'd be like, oh, I have no idea, because these are all kinds of weird, and it's not a function, and I have no idea. Okay, so this is a great time for your calculator to go through and make the calculations for you. So I would go ahead and again, pause the video. I know it's hard. Type these in. There's only 5 points. Run the regression and see what you get. Okay, I didn't answer part B and C before I did that, but that's okay. What type of association exists? I would say in general it's positive, but really it's not the best correlation in general. So we'll say positive. It says to draw a line of best fit. Again, I kind of said I don't want to, right? You don't really have that option when your teacher tells you to do something, but a line of best fit's really hard on this one. I would say maybe it'd be something like this, but it's kind of a yucky line of best fit just because those points are kind of scattered, okay? And then use your calculator. So the line that you should get is y equals 1.029x minus 1.382. If you did not get that, then go back and look at your data really closely to see if maybe you typed a number in wrong or you skipped a number, because that's going to change all the answers or all the numbers in the answer that you get. Okay? All right, number 5, I'm going to kind of breeze through the rest of these, but just make sure that you are pausing, especially if you're getting the last few wrong. Make sure you pause to check yourself before you just move on and write down the answers I'm giving you, okay? So number 5, they just give you a table. There's no graph this time. You don't have to graph anything. They say, what type of association exists? Well, when you do put this in your calculator, you're going to see the points. When you click graph, remember that that shows you a graph yourself, and you can see that the points are going to be going up. So this would be a positive association or positive correlation, same thing. Okay, again, it's hard to tell that if you haven't pressed the graph button to see what it looks like. What is the linear regression? Well, again, make sure you pause if you haven't done this. I'm going to write, what number am I on? There we go. Y equals 16.416x minus 621.826. Okay, then use your equation to estimate the number of cans with a temperature of 95 degrees. Well, that means the temperature was given to us as an x. I'm going to plug that 95 in for my x. Go Go ahead and pause if you haven't done this part. And you should get an answer of 937.694. Now, really, I would say 938, because we're talking about cans. You can't really sell a part of a can. Okay? Number 6, this is going to be the exact same process. The only thing that's different here is they haven't given you a pretty table to work with. If I were you, especially somebody who really works well looking at numbers and not so much looking at coordinates, which is me, myself, I would go through and just go ahead and transfer these coordinates to a table. So this first point here is 1, 2. So I'm write 1, 2. Next coordinate here is 2, 4. 2, 4. Next one is 3, 5. So then you're creating a table that then you can input into the calculator. Okay? So go ahead and finish out that process, put it in the calculator, and then find your linear regression. Make sure to pause the video while you do all that, so then you can check back to see if we got the same answer. You should get y equals 1.23 repeating, really, x plus 1.27 repeating, really, but 7, 8 is what we'll round it to. Last one, same exact process. Pause. Remember, the top is always your x and the bottom's your y. Pause and put that data in. And then it does say to predict the weight whose length is 75. So they're giving you a length. They're giving you an x to plug into the equation after you have it. So pause the video. So y equals 4.357x minus 156.143. And then the weight to be expected would be 170.632, and I don't know what the unit is, but we'll say pounds maybe. And you can have a decimal of pounds. That is allowed. So unless your teacher tells you to round on a problem like that, then I would just leave it as the decimal. Okay, so that is all the practice problems. I know this video was a little lengthy and a little bit weird just because you're having to look at that calculator. But again, if you have any questions, make sure to ask your teacher. This calculator is a huge tool available to you whenever you take the EOC at the end of the year. So this is a really good lesson to make sure that you understand and understand the benefits of. Okay, so talk to your teacher. Let us know if you have any questions. We'd be happy to help.